Morning, one and all. Good morning. The subject name is compiler design. In this subject, we are going to discuss about some of the problem solvings and implementations in this subject. And mainly now the concentration on how the problem solving can be analyzed with the help of, in this case, that is syntax directed translation and intermediate code generation. In previous discussion also, lecture also, we have seen some of the problems which are related to this in intermediate code generation, that is three address code and syntax directed translation, such as that is parse tree and parse tree notations, etc. Now let us see some of the problems here. Here also, how the three address code can be implemented with this type of structures. For example, in this expression, say here, here the expression is a into b. So that is, now we are going to, this one, it is to be calculated with a temporary variable, say t1. Now c plus t, you can take some another temporary, say t3. Now this is to be assigned with a new temporary t2 equal to minus t1, c plus t, that is t3. Now t4 equal to t2 plus t3. t4 equal to t2 plus t3. Now in this process, t4 equal to t2 plus t3. Once again, we will get what? A plus b. So a plus b we already we have arranged. So that's why here, for example, here a into b, you have taken three addresses. So three address code notation, where at least maximum three operands, and at least one operator is required. At least one operator is required. Three operands and at least one operator is required. So in order to satisfy this condition, this three address code is to be implemented with the help of this, like this statement: t1 equal to a into b. Now after this, we are going to implement t2, a new temporary variable is taken, and this is minus t1, because the result is already available in a into b, so minus t1. So let us take another temporary, say t3, and assign with the expression c plus t. So this is also in the three address. Why? Because t3, c, d, and the operands, and plus is an operator. So this is also an. Now after this, we are going to perform t4. t4 is the result of both the cases, that is t2 plus t3. So then we are going to implement a new temp, that is for a plus b, and t6 equal to, already c plus d is given. This is with this one. So that's why t3 plus t5, and finally the result is stored in t6. That is t6 is which contains a plus b, c plus d. Now t6 minus, that is what is already this one, it is stored in t4, result, previous result. So that's why it is to be. So these are all various temporaries which is used for the calculation of this expression, and to convert the given into a three address code format notation. So if you take this one, it is a three address code statement. It is also three address code statement, three address code. Why? Because each at least maximum three operands. Here t1 ab, operator is into, t2 t1 operands, operator is minus, t3 cd operands, plus is operator, t4 t2 t3 operands, plus is operator, t5 ab operands, plus is operator, t6 t3 t5 operands, plus is operator, t7 t4 t6 operands, minus is operator. So like this, we are going to make this every given into a three address code notation, and finally we reach the result in t7. Result is, why? Because t7 equal to t4 minus t6. What is t4? T4 is t2 plus t3 minus t6. Now what is T2 minus T1 plus T3? What is T3? C plus T. T6 is T3 plus T5. Now minus T1 plus C plus T minus T3. What is C3? T3 plus T5. That is A plus B plus C plus T. Now minus T1. What is T1? Minus A into B plus C plus D minus A plus B plus C plus T. Now this is the final result. What we got? Minus that is this result, which is same as the given expression. This is the given expression which you are getting. But this entire expression is divided into set of 3 address code notation, where the given expression does not contain 3 address code. So here there will be operands are A, B, C, D, and operators are plus, minus, into. So several operators. So it does not consider as a 3 address, but each is to be performed and final result is to be calculated. So in such a way that we are going to solve this type of expressions. And what is the syntax directed translation for assignment statement? So assignments in syntax directed translation, assignment statements is of the form that is equal to, that is ID equal to, and E1 plus E2, E equal to E1 plus E2, E1 star E equal to E1 E2. So like this, the translations can be done with the help of a semantic action rules. Here, what is the production? It is given S derives ID equal to E. See here, S is a dot attributed associated code for this value is S dot code, and E dot code which is going to generate this value, that is ID dot place, which is equal to E dot place. That means here the identifier and the non-terminal E, that expression value, can be both are equivalent by substituting the corresponding place value, that is address reference where this value is stored. So that ID dot place, which is equal to the place value. Similarly, we have to consider the next production, that is E derives E1 plus E2. Now in this we are going to accept a new temporary is to be created for the place value, that is E dot place and cloud. So we are going to write a 2-step notation where one is E dot place, another one is E dot code. So where the address of that particular reference of the instruction and temporary variable creation. So here it is a pipe symbol which is given, which is supplied the output and given as input to the another one. So finally this statement is to be generated. So what is the E dot place? It generate the addition of E1 dot place value plus E2 dot place value. Instead of place, the next production which carries out a star operation. So it generates E1 dot place star E2 dot place. So here the place value reference the address location where that value of the expression E1 is stored, and in terminal value, non-terminal value E2 where the value it is stored. Similarly, creation of new temp E place and E dot code. This is unary minus E1 dot place. And parenthesis expression E1 which specifies E1 dot place and E2 dot code. Identifier, simply you are going to write identifier E dot place and code value is null. So like this we are going to represent each of the corresponding production with the semantic action. Previous also we have described how the semantic actions are to be created. That is assignment in case of Boolean operator, that is operators which contains logical values, that is AND OR operator with respect to expression, AND operator, logical AND, relational operator, Boolean, true, false. So these are the different types of operators, that is the available in case of this Boolean expressions, and also logical values which computes this set of syntax directed translation schemes. Now how this can be implemented with the help of this one. You see, for example, the E1, that is G derives E1 or E2. So here we are going to create a temp, set new temp, and that is to be assigned e dot place. Previous directly you can also write e dot place equal to new temp. Previously also you have written, or you can write a two-step procedure also. Either of them is valid. Now here we are going to generate a t of this one corresponding. What is the e value? That is here e1. E1 which contains e dot place value or either e2 dot place. That means either of them is to be accepted. Suppose if both are included, then we are going to use an AND operator. But the address reference and returning that value both are same for this e1 and e2. Here also we are going to create place and create them. Here also creating the new temp. And finally, we are going to generate the temp with the not e1 dot place equal to. And here expression e1 dot place, e1 dot code, identifier same as this one, relational operator. So here in case of relational operator, it verifies, here it verifies after creating a new temp. Identifier is here, two identifiers are there, identifier 1, identifier 2. In between two identifier we are performing we are implementing a relational operator. So here if the identifier 1 of place and identifier 2 dot place, which in between the two identifiers the relational operator is to be included, and it verifies, then the condition is satisfied, then only it will go to the next quad plus 3. That means here condition is, suppose if the condition satisfied means result is true. That means identifier 1 plus that is what is the place? Suppose identifier 1 place is 10 and relational operator greater than, and identifier 2 plus 5, suppose in that, for example. So in this case, relational operator condition is satisfied. That means it is a true. If it is a true, then it passes the cursor to the next quadrant plus 3 with the cursor. That means 1, 2, 3. That means here 1, 2, 3 means third step. It generates a true value that is equal to t equal to 1. That means it is a true value. Suppose if that is a false, then in this case it won't execute go to statement, then it pass to the next statement will execute, then it generates t equal to g. That means condition is failed. Suppose if 10 less than 5, then it doesn't go to this next quad plus 3, then it goes to the quad plus 2. That means it skips off this one and go to the next line. This line onwards it will be executed. T equal to 0. Then it will go to next quad plus 2. Plus 2 means next skip off the next statement, followed by the remaining statements, it will be executed. So in this way, we are going to describe about the semantic actions which are to be performed in case of relational operators with the given grammars. So we have to verify whether that operator performs. So sometimes the expression which contains the statements, that is if condition, if else, and while loop, and list of statements. List of statement means statement 1, statement 2, like that, several list of statements, and then the individual statements followed by list of statements. So these are the different derivations which are available for the given grammar. So a statement can be an individual statement which contain if statement, or it may also contain if statement followed by else, or it may also contain while statement, or only the list of statement, only just list, or attribute assignment statement itself, that is L statement list, SC statement, B is Boolean valid expression. So like this we are going to specify the list of first one, S equal to if B S1. So here what is B? Boolean that is to be evaluated, B dot code. B dot code is evaluated to either true or false. So if the condition is true, then it is evaluated to S dot code. That means here where the true label is there. That means if the code then go to b dot true. So that is the label. It is here. It is separated with this colon, and b dot false with colon list of statements. So based on the code that is evaluated, here code means b dot code, which where if condition be the statement available, the condition that is available as a boolean expression. This expression is evaluated boolean expression. Based on this, it may go to either this or this. So here it go to be true whenever it is true value, and then list of statements the s1 dot code will be executed. That means following this one. Else, if it is false, then it won't execute the s1 dot code. Then if false list of statement, false block corresponding list. That means it skip off s1 and further go to the next line of statements. That is one case. Second one is an S, which includes this statement here. Else block is to be contained. So that means boolean followed by statement followed by else and then S2. So similarly, the procedure applied with this one as b dot code evaluation, condition checking. This is to be evaluated either true or false. So if it is true, then true block will be executed. If it is false, then false block will be executed. So suppose if the true condition, what are the statements? The next sequence of statement, that is s1 dot code, is to be executed, followed by s dot next. Go to s dot next means it skip off else block and go to this. The program continues with the remaining list of statements. Suppose if false is executed, then it won't execute the true block. It executes only the s2 dot code, and it goes to the next sequence of statement after continuation of this one. So these two true and false block is to be executed based on the condition satisfied. Whereas while it is a while, this condition is to be verified with this begin label begin and the condition evaluation. Here boolean expression evaluated either true or false. So true block statement 1 dot code, false block remaining statement. So here it is, suppose if the condition is true and true block is executed at s1 dot code, next immediately the go to begin. That means once again the loop will be executed. Go to begin means this label. Again condition checking true false, again true means it begin. Like this it is continuously executing where the condition false. Here false means it comes out. False means it comes out the corresponding statement, and remaining statements will be executed. Instead of continuing while loop, it comes out of this, and b dot false comes out of the while loop. It false means, and then the any sequence is there. It is further process of execution. So like this, the if condition while execution, we are going to create a new label as a semantic action rules. So previously I have given the diagram notation. Now the semantic action rules, what is the procedure means. Here we are going to create a label, a new label for the true condition. Suppose if this one is B, and if it is a simple statement, we are going to create a statement with the new label, and then code is assigned with the label that one. Our assignment statement simply s dot code equal to assign dot code. That means here left side we are having s, so s dot code. Right side we are having assign dot assign. Then we are going to perform the assign dot code. Similarly p dot code, right side s dot code. But s dot code where you are getting, so we are going to get the next statements. That means after executing this next statement. So next statement means s dot next. So that's why I am putting label s dot net. A new label is given, which is executing the further list next of this s. After executing any statements are there, that is to be executed with s dot next. So that is the labeling mechanism which is given. So that is following the process. So that means output is generated here, and for this output follows the remaining of this one is to be executed. Like this, in the case of if statement, suppose a label is created with the true and the false. Here false is to be assigned with the S1 dot next. Why? Because after S1, what is the statement that is executed? That is that is here S1 is executed means condition is true. So that's why label true S1 dot code is to be executed. So B left side here S dot code which is equal to B dot code. Here evaluation takes place and this evaluation leads to true. That means S1 dot code is to be executed. Suppose if that is label is false. Label is false. B dot true, not B dot true. Suppose if it is B dot false, then instead of S1 dot code, it execute S1 dot next. So what is the next statement? S1 is won't be executed. The corresponding next of S1 is to be executed. So you can say that it is equal to S dot next. That means the if condition. S dot next means if is completed, if B S1. So this is the S block. So after S means S dot next. So these statements will be skipped off. It won't execute. It go to the next. Similarly here B else S1 S else 2. That means we are going to create a true label and false label also. And then the left side statement code is to be equal to assigned equal to the code which is assigned Boolean expression evaluation to true and false. Suppose if true, what is the code? S1 dot code is to be executed. If it is false, S2 dot code will be executed. So that is the statement which is generated here. S1 dot code and S2 dot code. Create new two labels, true, false, and based on. Suppose if the condition is false, S2 dot code will be executed. Then if condition is true, S1 dot code will be executed. Then after executing this S1 dot code, then it goes to the next statement. What is the next statement? That is S1 dot next, which is equal to S2 dot next. That is equal to, that means completely if B S1 else S2. So this is the S assignment, S sequence of statements. Condition is true, S1, condition fails, S2. But if condition is true, what is executed? S dot next. If condition is fail, then S2 will be executed after that, S dot next. So this S2 dot next or S dot next is equal to S dot next. S2 dot next means S dot next, S2 dot next means S dot next. So that is to be executed with the corresponding node structures. And the while loop is to be performed with this boolean, same as here we are going to create a new label for the true case. Suppose here left hand side S dot code, the label is begin with boolean value evaluation, true or false. If it is true, the corresponding code will be executed, go to begin. Suppose if it is false, then each time begin is to be executed to continuous of the loop. Whereas if the condition is false, in this case, it won't execute S1, then it comes out. So S dot next will be executed, same as this one. And for finally this S1 followed by S2, which contains S1 dot next, a new label, S2 dot next, S dot next. So here sequence of statements, any sequence S1, S2, S3, S4 like this. This S may include several statements. So for each S, that is the code is generated. First execution of the code that is generated for S1 dot code, S1 dot code which is to be evaluated and given to S1 dot next. So next is S2. Again S2 dot code given S2 dot next. Again S2 dot next, S3 dot. Like that we are going to first create a label S1 dot next. Then S2 dot next is to be created with the help of S2 dot code. Like that all sequence of statements is to be executed with the help of this semantic action notation. So all the things which are available in this one can be found from this book, that is Compilers, Principles, Others, the Principles and Techniques, 3 others, Alfred's with Ullman. Thank you. We'll come up with a new topic with one more problem solving technique in a new chapter. Thank you once again.
Like, share and subscribe. hit the bell icon for more updates.